right, we're going to go over this AP free response question number 6. This was a problem that was, so let me just kind of tell you some background. Number 6 is on the AP free response question are the most heavily weighted problem on the AP exam. And then the other thing is that they are the ones that are the most out of the box thinking of problems on the exam. So, not only is it weighted the heaviest, what it does the idea is that it's an investigative task. It allows you to pull all the things you've learned about and maybe apply them in a new and different way. Now, when you do this, when you have a problem number 6, actually part of it is going to be um, part of it will be something you know. Okay, it's going to stem from something you know. So you'll start by doing something you know, and hopefully you can at least get 1, maybe 2 points from something you know. And if you can do that, if you can get 2 points out of the 4 points available for number 6, you're actually in good shape. Okay, anything after that is just like, man, you're awesome. Okay, so let's take a look at this problem here. It goes through the idea of probability distribution, okay, and applies different things. So we have this situation, okay, where here's what we have. And so they are assigning men and women to either the treatment or the control. And they have 2 men and 2 women. Now, one of the things that actually is really quite important is the order in which they assign the men and the women. And so to demonstrate, so what I have here, so this is actually really important to know that they go man 1, man 2, and then woman 1, woman 2. All right. So then they go through 2 different methods of assigning the men and the women of random assignment to the treatment and control groups. And so then they list out all the possibilities, and then you're supposed to say what to come up with the probability distribution. So let's do that. So our first described method is what's called a sequential coin flip. So what they'll do is they'll start with man number 1 and they'll flip the coin. And if it is tails, then the man will go to treatment. If it's heads, then he'll go to the control group. Okay. And then they'll flip the coin again. So see, independent situations. Then they'll flip the coin again. And then this man number 2 will go to either the treatment or control. Okay. And then they'll flip the coin again. And woman number 1 will go to treatment or control. And then by default, that woman number 2 will end up in the last place that is available. Okay. And it says, if as soon as one group, so if the treatment has, like if man 1 goes to treatment, man 2 goes to treatment, then that leaves the 2 women having to be stuck in the control group. So as soon as 2 people go to a group, then the remaining are automatically assigned to that other group. Okay, so here is how that works. So what you have to do is you kind of have to just walk through, baby step through the possibilities of what actually is happening for these arrangements to occur. All right, so here we go. Here's what happened. For man 1 to end up in treatment group, I flipped a coin and I got a tails. Okay, and then I flipped a coin again for man number 2, and that one was that I got a treatment for that one. I got tails. So that means then automatically both women go in the control group. So in order for arrangement 1 to happen, you had to have tails, and then you had tails again, and so that's how this arrangement occurred. All right, let's look at arrangement number 2, or arrangement B. So here we go. Man was in the treatment. Man 1 was in the treatment group. That means I flipped the coin and he got heads, or he got tails. So he went to the treatment. Okay. Then I flipped the coin again, and man number 2 got heads because he was put into the control group. And then I flipped the coin and for woman number 1, and woman number 1 got tails. So she went into the treatment group, which then puts the other woman in the control automatically. So the order of what happened, I had to have 3 coin flips, tails, and then heads, and then tails. All right, next. Man 1 flipped it. He ended up in the treatment. Man 2 flipped it. Let's see. Hold on a second. Okay, so here we go. So man 2 got heads. Okay, and then I flipped the coin, and woman 1 got heads. Okay, it's not going to change my probabilities, but it was that. I got tails, and then heads, and then heads. Okay, let's check these other ones. Okay, man 1, man 2, that was heads and then heads. Okay, next one, I went heads, and then tails, and then heads. Okay, and then I went heads, tails, tails. Okay, so it does look like I just had that one mistake. So I'll go in and fix that. So here we go. Once we do that, then now we come down here and we talk about, so what was the probabilities of those events? So that was the question. Complete the table below by calculating the probability of each arrangement. So in order for A to happen, I had to get tails and then tails. And so that's a 0.5 times a 0.5. So that will happen 25% of the time. In order for arrangement B to happen, I had to get a tails and then a heads and then a tails. And then C was tails and then a heads and then a heads. But C is still the same probability. And then arrangement D was heads and then heads tails. Okay, and so on. So you can see then how I came up with those numbers. So this is what you needed to get to fill out that table. Okay? Now the question then is this. For the sequential coin flip method, what's the probability that man 1 and man 2 are assigned to the same group? So that's they both are in A or they both are in D. So that's what happened. So see, I can see up here. It was this. Arrangement A had the men in the same group. Arrangement D had the men in the same group. So that means 50% chance. So there's a 50% chance. With this method, there's a 50% chance that the men are going to end up in the same group, either both in the treatment or both in the control. Okay? So, and do keep in mind, those events are independent. So from coin flip to coin flip, it still stayed 50%. Now, let's take a look at the next page. Here's what happened next. The arrangements are just reprinted here because of the page turn. Okay. But here we have a different situation. So let's read the process for this one. Here we go. For the chip method, so we have a bag, and in this bag, so here's our bag, and we have put the chips in here, like poker chips, okay? So 2 of the chips have a T on it, and then 2 of the chips have a a C on it for control, okay? So you could think of it like that. So each person selects a chip, but look, without replacement is a big deal. Without replacement. So that means, so we're going to start. Let's start. Here comes man number 1. Come on, man number 1, pull out a chip. Here we go. Man number 1 pulls out a chip, and I can see he got the treatment group because he's in the treatment group. Okay, guess what? That chip stays out. So now, how many chips are in here? You have to think, what is left? So what is left now is 3 chips, and one of them, only one says treatment, and 2 of them say control. Okay, so come on, man number 2, you come on. And so he's going to come in here and he's going to reach in here. And he pulled out, look, he got in the treatment group again, which is very interesting because that was a reduced probability. Let's take a look at that. See, look, the first guy who came up, 2 out of the 4 were for the treatment group. But when that second guy came up, there was only 1 out of the remaining 3 that were for the treatment group. Okay. All right. Next. Let's do the next one. Here's arrangement B. Okay, so what happened here was so here we go. Man number 1 came up. And so all the coin, by the way, all 4 coins back in here. Okay, so come on, man number 1. Here we goes. Pulls out a coin or a chip, and it was a treatment group. So it was a treatment group 1. So that is 2 out of the 4 coins in here were treatment. Okay. Next, come on, man number 2. Remember, because we go man 1, man 2, woman 1, woman 2. Come on, man number 2. Okay, so he reaches in and he pulls out a chip. Well, he got this. He got the control. So let's take a look at that. See, of the 3 that were here, 2 of those 3 were control at that time. Okay. All right, now let's see what happened. Come on, woman number 1. She comes up. So now what's left in here? Okay, let's think about it. What's left in here? 2 chips. One says treatment and one says control. So she's going to come on up and, oh, lo and behold, she got the treatment. So that was, she had a 50-50 chance. So there it was. 2/4 times 2/3 times 1/2 is really what's happening. Okay? So then that's how we have to go through that process, okay? And so let's do one more. Arrangement C. Okay, so remember, all the chips are back in the bag. So here we go. Come on, man number 1. What did man number 1 choose? He reached in the bag and he got the treatment. So that is the 2 out of the 4. Okay, come on, man number 2. He reaches in there and he picks a control group 1. Well, remember, there were 3 coins in there, or 3 chips, and 2 of them said control, and only 1 of them had treatment. Okay, so 2 out of the 3 were control. Okay, next, woman number 1, she got the control, which was a 1/2. So we go through that process again for the other remaining ones. And it takes some thinking, okay? So I had to just go through laying out. You have to do this. You have to go through physically each one of those probabilities. And so I did. And then once you computed them on, it was so interesting that the probability of all those were the same. And so then that meant that for man 1 and man 2 to be assigned to the same group, then that was arrangements A and D again. So it's 33.33%. So that's interesting. That's very interesting. So what that tells me is that when you had independence, okay, of the choice, then there was a higher chance, 50% versus 33% chance, for the same gender to end up in the same group. Okay? So then now here is where, so technically those two parts were not the out of the box thinking parts. Okay? Those were the in the box, and I think that I think you would have gotten 2 points from those 2 parts. This part would have gotten you the 3 part, or the other 2 points. So here we go. Then they have a whole new situation. They say, hey, you know what? Okay, new situation, but we're going to consider these 2 methods. We have 16 participants, 10 are students, and 6 are teachers. So we have 2 different kinds of things, like how we had men and women. Here we have students and teachers. And they're going to be experimenting and determine lunch preference. And so as the participants enter the school cafeteria, then they're going to be randomly assigned to receive either one of 2 lunches. So 8 will get a salad and 8 will get a grilled cheese sandwich. So at this point, I'm already thinking to myself, salad versus grilled cheese and student versus teacher. There's an issue there. I'm thinking, okay, I've already can see some potential bias occurring, some confounding variables, because the students, if I get more students that get the grilled cheese or whatever, they're going to like that, or however this works, okay? So the students will enter first, kind of like how we did man 1 and man 2. Well, now we're going to go all the 10 students and then the 6 teachers. Which method, the sequential coin flip or the chip method, should be used to assign the treatments? Justify your choice. Okay. So this is bringing in the concepts of these random variables plus your understanding of experimental design. I can see that if I had if 8 people that got the salads were 6 teachers and 2 students, then we're going to have more people liking the salad. And conversely, what happens if 8 of the people who get the salad were all students? Then what is our conclusion about salad going to be? They very well could say, bleh. So we want to avoid getting all 8 people that are going into the salad group being all students. So we want to avoid having all the same kind of people in one treatment group. That's the goal. So I would use the chip method. So I made my statement. I want to reduce the possibility of getting the same kind of subjects in any group. And then here's why. Because the fact that you are a student or a teacher may affect your lunch preference. The choice of you being a student or a teacher, or the fact that you're a student or a teacher, may affect your lunch preference. So that's a lurking variable or a confounding variable, because the fact that you're one thing could affect your choice. So I want to control that. So the chip method makes it less likely for the subjects of the same kind to end up in the same treatment group. See, as evidenced by this section here, chip method, 33% chance. Here, it was 50% chance, okay, that you had same subjects. So therefore, the extension is saying, okay, then that means I want to do the chip method, because it's a smaller chance of all the same subjects ending up in that same group, which could then bias the results. Okay, big problem. But do you see how tedious a probability distribution could be? You had to just baby step your way through this to get these numbers. You couldn't willy-nilly just go, oh, okay, that's probably about the same or whatever. No, it took actual computing to get those values. All right, so I hope that makes sense. I hope that helps you understand the depth of these problem number 6s on your free response, so that you can do well and you'll dive into that depth of content on your problem number 6s that you see in the future.